Right now, as you're watching this video, there's something absolutely mind-bending happening 93 million miles away. The sun, this seemingly boring yellow ball of light that you've taken for granted your entire life, is literally tearing itself apart. Massive explosions the size of Earth are erupting on its surface. Magnetic storms are brewing beneath layers of plasma. And we're about to dive so deep into the heart of our star that you'll never look at a sunrise the same way again. What we're about to show you is the most advanced imagery and data humanity has ever collected about the sun. And trust me, what's actually happening up there makes science fiction look boring. So stick around, because we're about to take you on a journey that astronauts will never experience, through territories that our eyes can never see, into the deepest mysteries of the star that literally keeps you alive. Okay, let's start with something that should absolutely blow your mind. When you see sunlight, you're not seeing fresh sunlight. You're watching light that's been on a journey through absolute chaos. Here's the wild part. The light hitting your face right now, it took about 8 minutes and 20 seconds to travel from the sun to Earth. But that photon, that tiny particle of light, spent anywhere between 10,000 and 170,000 years just bouncing around inside the sun before it was even allowed to escape. Think about that. 10,000 to 170,000 years. That's not a typo. That's what we're talking about. A single photon of light gets created deep inside the sun's core through nuclear fusion, and then it has to squeeze through 432,000 miles of plasma in complete darkness, getting bounced around like a pinball in the universe's most crowded arcade. Every time it bumps into an atom, it loses energy, gets absorbed, gets re-emitted. It's essentially trapped in the world's most chaotic light prison. And when it finally escapes the sun's surface, it's traveled so far and bounced so many times that it's a completely different photon than when it started. But here's where it gets really interesting. Scientists figured this out by studying something called the solar neutrino problem. They measured how many neutrinos came from the sun compared to how many they expected, and the numbers didn't match. The universe was basically messing with them, saying, "Nope, you don't understand the sun yet." And they were right, because what we thought we knew about the sun was just scratching the surface, literally. Now here's where technology becomes absolutely legendary. You can't look at the sun with your regular eyes. I mean, you can, but you'll go blind, which is a bummer. But scientists figured out something genius. Why look at the sun in just the regular light we can see when you can watch it in invisible light? This is where things get trippy. The sun doesn't just emit the visible light that paints your sunrises and sunsets. It's screaming across the entire electromagnetic spectrum like a cosmic rock concert. We're talking ultraviolet light, X-rays, radio waves, infrared radiation, basically everything. And when you start tuning into these invisible channels, the sun transforms from being this calm, boring star into an absolute madhouse of activity. NASA's Solar Dynamics Observatory, this incredible satellite that's been watching the sun since 2010, uses extreme ultraviolet light to capture images that make the sun look like an alien world. And honestly, it kind of is. With this technology, we can finally see what's actually happening in the sun's outer atmosphere, called the corona. The corona is absolutely bonkers. It's around 1 million Kelvin, hotter than the sun's own surface, which is already 10,000 degrees Fahrenheit. Wait, what? Hotter on the outside than on the inside? That's like your skin being hotter than your internal organs. And scientists still don't fully understand why. It's called the corona heating problem, and it's been baffling physicists for decades. But that's not even the wildest part. In the corona, you get to witness the sun's most dramatic tantrums, solar flares and coronal mass ejections. Imagine the magnetic field lines around the sun suddenly getting twisted and tangled, like you just grabbed a bundle of yarn and went haywire. That tension builds up and up and up until, boom! All that energy releases at once in an explosion of radiation. We're talking about energy equivalent to billions of nuclear bombs detonating simultaneously. And these happen regularly, sometimes multiple times a day during peak solar activity. When one of these massive ejections points directly at Earth, our satellites get fried, power grids shut down, and we get some of the most spectacular auroras ever. But that's the thing, the sun doesn't care about our infrastructure. It's just being itself, and itself is absolutely insane. Let's talk about the actual structure of the sun, because it's basically a cosmic onion, and each layer gets weirder the closer you look. Starting from the outside and working our way in, you've got the corona, that million Kelvin outer layer we just talked about. But beneath that is something that should make physicists lose sleep: the transition region. This is only about 100 kilometers thick. That's shorter than the distance a commercial airplane flies at cruising altitude. But in that tiny, paper-thin layer, temperature shoots up from about 8,000 Kelvin to 500,000 Kelvin. Not gradually, sharply. It's like walking through a door and going from a comfortable room temperature to the surface of Venus. Scientists call this the chromosphere, and it's where things start getting visually insane. In the chromosphere, you get phenomena called spicules. Imagine a jet of plasma just shooting straight up at about 100 kilometers per second. That's 224,000 miles per hour, just because the magnetic field said so. These things are everywhere, constantly popping off the sun's surface like cosmic popcorn. They occur when neutral particles and charged particles interact in ways that build up pressure, and then the whole thing just rockets upward. Some of them fall back down as something called coronal rain, which is exactly as beautiful as it sounds. Plasma literally rains down from the sun's atmosphere like the universe's most violent weather system. But sometimes, instead of raining down, these massive loops of plasma called prominences or filaments just keep rising, arcing hundreds of thousands of kilometers out into space. And sometimes they get ripped away as coronal mass ejections. These are the big boys, the solar hurricanes that can take down a satellite faster than you can say, "My Wi-Fi is out." Then you've got the photosphere. And here's where it gets funny, because scientists call this the surface of the sun, but it's not actually a surface. It's not solid. It's not even defined by a clear boundary. The photosphere is about 400 kilometers of pure plasma that just happens to be less opaque than the layers beneath it, so we can see some stuff happening there. It looks like there's a surface because we hit a point where photons can finally escape. But it's basically the solar equivalent of the horizon, a line where our ability to see clearly just ends. On the photosphere, you see sunspots. These are areas where the sun's magnetic field is so intense that it actually prevents some heat from reaching that area, making it about 1,000 degrees cooler than its surroundings. Now, 1,000 degrees cooler might not sound that dramatic, but on the sun, that's like a snowstorm. They appear as dark blotches because they're cooler, which makes them darker than the surrounding plasma. It's basic physics. And you also see these structures called granules. These are massive convection cells, like bubbles of plasma rising and falling, each one roughly the size of Earth. They churn at supersonic speeds, moving plasma around at speeds that would make hurricanes look like gentle breezes. The entire photosphere is basically a boiling ocean of plasma that never stops moving. Here's something that might surprise you. The sun isn't randomly chaotic. It has a rhythm. It has a heartbeat. The sun follows an approximately 11-year activity cycle, and during this cycle, the amount of wild stuff happening, sunspots, flares, coronal mass ejections, increases and decreases like waves in an ocean. Right now, as I'm recording this in 2025, we're actually heading into what's called solar maximum. The next few years are going to be absolutely bonkers. Expect more auroras, more solar flares, more power grid issues, and more incredible satellite imagery showing the sun losing its mind. During solar maximum, sunspots can cover about 2% of the entire solar surface. During solar minimum, there might be weeks or even months without a single sunspot. The reason? Magnetism. The sun's magnetic field is incredibly complex. It's not like Earth's, where you basically have a North Pole and a South Pole. The sun's magnetic field is like having thousands of local magnetic regions all fighting each other simultaneously. Every 11 years, the entire field essentially flips. North becomes south, south becomes north, and in the chaos of that flip, all kinds of wild stuff happens. Scientists believe this cycle is related to something called the solar dynamo. Basically, the movement of plasma deep inside the sun creates and maintains the magnetic field. And that plasma movement isn't smooth or predictable, it's turbulent and chaotic. This is why predicting solar activity is incredibly difficult. We can see the patterns, but the underlying mechanisms are still partially mysterious. What we do know is that this 11-year cycle has massive implications for life on Earth. Solar activity influences our climate, affects satellite technology, impacts radio communications, and creates the auroras that look so beautiful. The sun isn't just a distant star that we can ignore, it's an active participant in everything that happens on our planet, and its moods matter. Okay, so we've talked about the sun's atmosphere and surface, but here's the frustrating reality. Scientists can't look beneath the photosphere. We can't see the convection zone or the radiative zone, or most importantly, the core, where all the actual nuclear fusion is happening. It's like trying to understand a person by only looking at their skin. But here's where humans get creative. Since we can't see directly into the sun, scientists developed something called helioseismology. Basically, they study the vibrations and oscillations on the sun's surface. These are caused by sound waves bouncing around inside the sun's interior, and they use these vibrations to map out what's happening inside. It's kind of like doing an ultrasound of the sun, except the ultrasound is made of light and science instead of actual sound waves. And through this technique, we know that there's a convection zone just below the photosphere where massive plumes of hot plasma rise up, cool down, and sink back down. We know there's a radiative zone below that, where energy travels in the form of radiation rather than physical movement. And at the very core, there's nuclear fusion happening at a temperature of 27 million degrees Fahrenheit. Hydrogen is being fused into helium at a rate of about 600 million tons per second, and this process has been happening for about 4.6 billion years and will continue for another 5 billion years or so. But even with helioseismology, there are mysteries. We still don't fully understand certain aspects of the sun's internal dynamics. We don't fully understand why the corona is so hot. We don't fully understand all the complexities of magnetic field generation. And honestly, that's what makes solar science so exciting. There's still so much to discover about the star that's literally the reason you exist. We're living in an age where we have more data about the sun than ever before. Yet we're constantly discovering that the sun is more complex, more dynamic, and more fascinating than we ever imagined. Future missions like the Parker Solar Probe will get even closer to the sun than we've ever been before, collecting data that will revolutionize our understanding. And who knows, maybe someone watching this video right now will be the person who solves the corona heating problem or discover something even more mind-blowing about our star. So here's the reality. The sun isn't the boring, static object that most of us imagine when we think of it. It's a turbulent, violent, incredibly dynamic engine of plasma and energy. Every single day, it's undergoing explosions, magnetic storms, and plasma eruptions that dwarf anything happening on Earth. And yet it's so incredibly fine-tuned for creating life that even a slight change in its output could render our entire planet uninhabitable. The deepest we've ever seen into the sun has shown us that what appears to be a steady ball of light is actually one of the most complex and fascinating objects in our entire solar system. But we're only scratching the surface, literally. There are still mysteries waiting to be solved, phenomena waiting to be understood, and revelations waiting to change how we see the universe. If you found this deep dive into our sun as mind-blowing as I did, make sure to hit that subscribe button because we're constantly exploring the cosmos and sharing the kind of content that makes you question everything you thought you knew about space. And here's my question for you. Knowing that the sun is this chaotic, dangerous, and incredibly powerful object, does it change how you feel when you look at a sunset? Drop your thoughts in the comments below, and let's talk about what it really means to live under such an incredible star. Thanks for watching, and I'll see you in the next one.